Hi, this is a podcast that is supposed to help you with writing formulas for ionic compounds. We went over the rules earlier in class, but this is just so that you can kind of work through the examples at your own pace. Feel free to stop and rewind if you need to hear something again. Also, feel free to ask me any questions that you need to in order to make things clear. So this is meant for you to be able to work at your own pace. A really quick review of what we just talked about. Ionic compounds are made of cations and anions. Cations are positive, anions are negative. In order for an ionic bond to work, the two have to cancel. So your charges from your cations have to cancel the charges of your anions, and that's what's going to make it neutral. That's why every time you touch something, you don't get shocked. And in order to show this, we're going to write chemical formulas that show the elements involved and their numbers. So in H2SO4, sulfuric acid, H is for hydrogen. The little 2 behind it is a subscript that shows that there are 2 atoms of hydrogen. But then there's the S, stands for sulfur. You'll notice there's no subscript there. No subscript means a 1. And then the O for oxygen, and then there's 4 atoms of that. Remember, these are counting numbers. So like if I actually looked at this molecule, I could count 2 atoms of hydrogen, count 1 atom of sulfur, and count 4 atoms of oxygen. Okay. On your periodic table earlier, we put charges on there, and so this is just a quick reminder in case you didn't get those written down. Remember, your metals make your cations, and so that's why they have the positive charges. They're going to lose all their valence electrons. Your nonmetals make your anions. They're negative charges because they're gaining the electrons. Remember, there's a transfer going on there. Your noble gases, group 18, don't have a charge at all because they already had 8 valence electrons. Remember, the goal is to get 8. And the transition metals in group 4s can have multiple charges. Remember, I gave you this sheet called the common ion charges sheet that has all of them listed for you. Well, when we're writing their formulas, the name of the ion is going to have the charge as a Roman numeral in parentheses behind it. So that's how we're going to figure that out. So really quick recap, you write the symbols for the elements, you write their charges up in the upper right hand corner just like you write exponents in math class. If they cancel, then you just get to smush them together and rewrite it so it looks like a word. If they don't, you crisscross them, and that's going to help make them neutral. And I'll show you that as we go along. If you have a polyatomic ion and it has it needs a subscript, then you have to put it in parentheses, and I'm going to show you some examples of those. So here we go. We're going to start with sodium chloride. Sodium is a group 1 metal, so it has a positive 1 charge. Chlorine is a group 17 nonmetal, so it has a negative 1 charge. Well, +1 and -1 equals 0. So we say that they cancel. Well, when they cancel, that means everything is electrically neutral. And so our positives and our negatives equal each other. So we're just going to smush it together, and we're going to have NaCl, table salt. Okay. You also can have calcium oxide. Calcium is a group 2 metal, so it has a +2 charge. Oxygen is a group 16 nonmetal, so it has a -2 charge. +2 and -2 cancel. And so because of that, we can just smush them together, and we get CaO. Aluminum sulfide is Al +3, S -2. So I got those charges by looking at my periodic table. Well, in this case, the +3 and the -2 don't cancel. So what I'm going to do is cross my charges. And so what I mean is I'm going to look at these charges back here, and there is a charge, like a plus and a minus, and there's a number. I'm going to take this number 3 and put it behind my sulfur. I'm going to take this 2 and put it behind my aluminum so that my formula ends up being Al2S3. Now here's why I do that. Remember, these little subscripts are counting numbers. So I've got 2 ions of aluminum. Well, each of those ions has a +3 charge. So total, I have +6. This sulfur, I have 3 of them. Each sulfur ion has a -2 charge. So I've got a total of -6, and that's my goal. The +6 cancels with the -6. Okay, so that's why I cross the charges. If I do that, then every time it's going to end up canceling for me. Iron 2 chloride. Iron is a transition metal, so behind it you're going to find its charge. So Fe plus 2, and then chlorine is Cl minus 1. The 2 and the 1 don't cancel, so I'm going to have to cross them. Now remember, I never write the number 1. So this 1 back here is going to end up being not written. If you don't see it, assume that it's a 1. Lead 4 oxide. Lead is Pb plus 4, so that's what this Roman numeral is telling me back here. And then you have O minus 2. Well, when I cross their charges, I get Pb2O4. Now here is one thing that you gotta watch for, and you're most likely to see it when your cation is a plus 4. And that is for these guys to not be in lowest terms, for your subscripts to not be in lowest terms. So do you notice that the 2 and the 4, you can divide them both by 2? Well, when you do that, you get PbO2. Okay? And that's just so that we don't end up with more leads or more oxygens than we really need in our compound. Calcium carbonate. Do you notice how this ends in 8 and everything else is ended in IDE? The ATEs and the ITEs are polyatomic ions. So far we've just been dealing with ions that are one element. Polyatomic ions have more than one element. So for example, carbonate is carbon and oxygen together in one ion. 1 atom of carbon, 3 atoms of oxygen. But we memorized these for a reason, so that whenever they pop up, we're going to recognize them. The best thing to listen for is ATE and ITE, and that's going to help you remember that those polyatomic ions that I made you memorize, one of them is going to show up in here. So I'm going to look at the plus 2, the minus 2. They cancel, so same rules we've been doing. You're just going to smush it together, and it's going to be CaCO3. Magnesium acetate. So we have Mg plus 2, and then acetate is a minus 1 ion. So the plus 2 and the minus 1 don't cancel. I'm going to have to cross the charges. So you're going to get a 1 behind the acetate, and you're going to get a 1 behind the magnesium, and a 2 behind the acetate. So it'd be MgC2H3O22, but C2H3O22 is not acetate. We have to be able to recognize acetate in our formula. So what we're going to do is protect it by putting parentheses around that acetate. It's going to work kind of like a shield does. So that we've got acetate in parentheses that we can recognize, and then there's a little 2 out here that says that there are 2 ions of acetate instead of 22 atoms of oxygen, which is what this looks like. Ammonium sulfate. Both of these are polyatomic ions, so ammonium is NH4 plus 1, sulfate is SO4 minus 2. You've got a plus 1 and you've got a minus 2, which don't cancel. So we're going to have to cross our charges. There's going to be a 2 that goes behind our ammonium, so we're going to have to protect it with parentheses. And then this 1 would go behind my sulfate. But because I never write the number 1, I don't have anything to protect my sulfate from. So that's why my sulfate isn't going to get parentheses around it like my ammonium did. I hope this helps. At the end of the other podcast, you're going to find a PowerPoint slide that has 5 examples for you that's going to mix writing names and formulas. So if you need any help, just let me know.